Hello, today's video we are talking about congruent polygons. So a reminder, what is a polygon? So a polygon is your triangles, right? Your quadrilaterals, your pentagons, hexagons, all right? So all of those figures that are closed with segment sides, okay? So when we talk about congruent polygons, how do we know two polygons are congruent to each other? So congruent polygons can be mapped onto one another. By a sequence of rigid transformations. And so when we talk about rigid transformations, oh my gosh, if I could spell today. What we're talking about when we talk about those rigid transformations, those are the four transformations we've kind of talked about. So we have our translations, we have our reflections, our rotations, and our glide reflections. We briefly talked about that, but glide reflections are also included there. Okay, so those are the four rigid transformations. So you can see we can slide, we can flip, which is the same thing as reflect, or we can turn / rotate. Okay, so those are kind of the main things we can do, or we can do a combination of those. So when we talk about congruent polygons, it's really important to get our notation correct. So here we see that we have this quadrilateral over here, quadrilateral XBCA, is congruent to quadrilateral YQRP. And so it's important to look at the pieces that correspond to each other. So this one is color-coded. So C corresponds to R, angle B corresponds to angle Q, segment AX corresponds to segment PY, and therefore when I write the congruent statement, I want to make sure I put the order of the letters in the way they correspond. So ACBX would then be congruent to PRQY. If I wrote it as, let's say I said XBCA, I would need to make sure that I went from XBC to A, then I'm going to go from YQR to P. So now if I look at this, I know that when two polygons are congruent, all of their corresponding pieces are congruent. So the corresponding pieces or the corresponding parts are my angles and my segments that make up those. So for instance, if I have a triangle TJD and I know it's congruent to triangle RCF, I know angle T congruent to angle R because they're in the same spot. When I write my congruent statement, I know that angle J and angle C are congruent. And lastly, I know that angle D and angle F are congruent. And same thing with the segments. So I can say segment TD is going to be congruent to segment RF, segment TJ is congruent to segment RC, and segment DJ is congruent to segment FC. So then when I say list the congruent corresponding parts, this is what I'm going to do. I'm going to say angle T congruent to angle R, angle J congruent to angle C, angle D congruent to angle F. Okay, so those are my three angles, and then I'm going to list my segments too. So when you're typing this, you can write the words congruent to, since you don't have access to the symbols, that's okay. So I might say segment, and I type that word segment, TJ, congruent to segment RC. Segment JD is congruent to segment CF. And segment TD is congruent to segment RF. Okay, so there we go. Our corresponding parts for triangles, you're going to have 6 corresponding parts. Next, if I know they're corresponding, then they're going to be congruent. So if I know that triangle WYS is congruent to triangle MKV and angle Y is 35 degrees, what is the measure of angle K? Well, I can see that K and Y are both the middle letter. Therefore, those angles in that position are going to be congruent. So the measure of angle K is going to also equal 35, and it's because angle Y and angle K are corresponding. Corresponding parts of congruent triangles. All right, next example. Decide whether the triangles are congruent and justify your answer. So if I look at these two triangles, remember for triangles to be congruent, I need all of the pieces to be congruent. So I have, let's check my angles. So they both have a right angle, check. They both have an angle marked congruent, check. My third angles. Well, these angles here are vertical angles. So angle ECD and angle ACB are congruent by vertical angles. So let's write this all down. So I have angle E congruent to angle A. Okay, that's marked. I have angle B congruent to angle D. Okay, those are right angles. And then I have angle, and I can't use one letter because there's more than one letter, more than one angle that has letter C as a vertex, so I need to use 3 letters for these. So angle BCA is congruent to angle DCE, okay? And those are vertical angles, all right? So I have all 3 angles, and then let's talk about my segments. So if I look at my segments, I know BA and ED have the same measure. BA is congruent to ED, okay? And same thing with BC and CD. BC congruent to CD, okay? So these have the same measure. And then my last segment, I can say AC is congruent to CE, and that's because it's marked. Okay, that's marked congruent for me. All right, so now we got a theorem. It says if 2 angles of one triangle are congruent to 2 angles of another triangle, then the third angles are congruent. So if I have angle A congruent to angle D and angle B congruent to angle E, then I must know angle C would have to be congruent to angle F. Okay, and this is because, remember, they have to add up to 180 degrees. So if I know A plus B plus C adds up to 180, and D plus E plus F adds up to 180, and A and D are the same, and E and B are the same, then by process of elimination, C and F would also have to be the same. Okay, and you can prove that with addition, subtraction, if you wanted to. So let's figure out how we can use this theorem to talk about proving triangles are congruent. So if I want to prove triangles are congruent, I need to show all 6 pieces, all 6 parts are congruent. Okay? So you can either do these in a table proof, you can do them in a paragraph proof, you can just list the pieces and say you know why. So let's list the pieces. All right. So if I look at these 2 triangles, triangle PQR and triangle SQR are both halves of this kite figure I have. And they look like they're a reflection of each other. Okay, so I want to make sure all of those 6 pieces are corresponding. So let's start with the segments. So if I have PQ, I know that that's congruent to PS, and that's marked. My next one is that QR is congruent to SR, and that's marked. Okay, so I've done this one, and then this set here. Great. And now if I look, they share a side. So they share that third side, PR. Well, PR, of course, is congruent to itself. And the official way we say something is congruent to itself is called the reflexive property. Okay, so the reflexive property says things are congruent to themselves. All right, next, let's look at the angles. So the first angle I notice is that Q and S are congruent. So angle Q congruent to angle S. And that is marked. Then I also have that this angle here, QPR and angle SPR are also marked. Okay, they have a little marking there too. So angle angle QPR is congruent to angle SPR. Okay, and that's marked. And then my last angles are these angles down here on the bottom. So angle QRP is going to be congruent to angle SRP. And so for this one, this uses this theorem. So this theorem says if two angles of one triangle are congruent to two angles of another triangle, which I have right here, I have the two angles, then the third angles are congruent. Okay, so you can say third angle of triangle. Third angle, triangle, I don't know. Third angle, let's call this the third angle triangle theorem. Third angle triangle theorem. Let's give it a name. You could officially call that. Let's put that title up here. Third angle triangle theorem. Okay, it's officially its name. Okay, and that's all I have for you today. The last example on here, you may have seen it, but that's actually part one of your homework problems. So you can do it very similar to how we just did this proof. All right, thank you.